but this is a basic idea. So what is the reliability of a TMR? And as we have calculated that formula there, for R equal to 2 to 3, there are two good combinations. When all three of them are good, and secondly, when two of them are good and one is bad. If two of them are bad or all three of them are bad, those are the bad cases, right? So, 3 choose I, Ri, 1 minus R raised to 3 minus I, and you can solve that and it will turn out to be PR squared 1 minus R plus R cubed, and that will solve to 3R squared minus 2R cubed. Now this assumes assuming a perfect water. Here we are assuming that the water is perfect. Is that a good assumption? That the water is perfect? It's a reasonable assumption if the complexity of this is much smaller than the complexity of this. So each of them, if they are much more complex than the water, then the probability of the water being bad is low, and hence reliability is basically determined by this. However, if you want to consider the probability that the water could be bad, you have to multiply this by the probability of the water. In fact, if you want to come up with a more exact expression, multiply the whole thing by R sub V, where R sub V is the reliability of the water. Now there's another way you can, here's an alternative way. So notice that the system is good when it's a good system when you have 3 of the modules are good, or when 2 of them are good. And hence, the reliability of the system is equal to when all 3 are good and when 2 of them are good. And there are 3 choose 2 ways they could happen, and 1 minus R squared multiplied by R, and you get the same expression. Basically, more or less the same thing. Both calculations, they are basically, in that case we started with a formula, and in this case we started from scratch, but if it is correct you should get the same answer. So TMR is a powerful is a popular scheme for very highly reliable systems. There is significant overhead. Overhead moves more than 3 times, right? Well, I should say overhead more than 2 times. So this is overhead, and this is overhead. So significant overhead, but in some cases it may be worth the cost if you think that it gives you enough improvement. Let us consider for TMR. Let us consider TMR permanent failures. And let us assume that reliability of an individual module is equal to e raised to minus lambda mt. Then what is the overall reliability of TMR? Okay, so reliability of TMR is obviously going to be 3 e raised to minus 2 lambda mt minus 2 e raised to minus 3 lambda mt. And okay, let's calculate MTTF. Okay, why don't you calculate MTTF for TMR, since you know how to do it. And I will give you a clue that all you need to do is to take the reliability of TMR in terms of time, integrate it over 0 to infinity, and that should give you the answer. And that will give you okay. So, okay, go ahead and try this and let us see what you get. Now remember, for one thing that you should remember in integral calculus is that integral of e raised to minus x dx, that is equal to e raised to minus x. Of course, if you have e raised to minus, let's say, ax, then it has to be divided by a.
Minus
Is that correct?
the minus sign.
Oh yeah, I want the minus sign. Yeah, that is true. Forgot about the minus sign. Yeah, you have to have a minus sign there. And so you put that in and take a few seconds, and you get 5 by 6 lambda. Okay, is that good or not? Does it look good? 5 by 6 lambda? Or you think it's not good? Well, compare it with an individual module. Compare for a single module, MTTF is equal to 1 by lambda. So, the MTTF of a TMR system, and as I was mentioning, it is used for highly reliable systems, is actually less than that of a single module. And the reason is that MTTF is not a good measure for very highly reliable systems. So basically, by the time you come to MTTF, you are approaching or in the region where each individual module has a reliability that is sufficiently low. In fact, you could do a little calculation here. Let us make a plot. Oh, incidentally, you have to be able to use Excel. We will be using some kind of computational package. So I'm assuming that you all can use Excel. So you can plug in numbers, do some analysis, and you should be able to make plots. So it could be needed for one of your assignments. So what, has anyone used any of the other mathematical packages other than Excel? So you have all, has everyone used Excel? Okay, has anyone used any other mathematical packages, like the statistical packages, what is it? MATLAB, any MATLAB? You have used MATLAB? Okay, that's a good package. And some of the others. Okay, so I was going to mention something. Now this is the sort of the plot that we had seen earlier. And here the reliability. Here is 1, here is 0.5. Now if you will plot the reliability of a single module, this is a single module, and if you plot the reliability of TMR, things will look like this. So notice that when reliability of an individual module drops before 0.5, it is going to worsen the reliability of TMR, which is based on voting, right? Okay, so what is good about TMR? Okay, and incidentally, let me, for illustration. Now, we will see that the great thing about TMR is that it is highly effective for temporary faults. But before we come to temporary faults, let us also calculate the mission time as an exercise. So the threshold reliability is equal to 3, same formula there, e raised to minus 2 lambda, let me just call it lambda, T sub m minus 2 e raised to minus lambda T sub m is the mission time that we want to calculate. And so you have to calculate, okay, so this is given, and let's assume that perhaps this is equal to 0.95. How can you solve this equation? Now in some cases you will have to solve things numerically, because here it is in the power here, in the power here, and it is hard to isolate it. And so, but you can always solve it numerically. And essentially for one, has anyone solved any things numerically before? If you have to solve something numerically, there's one good thing in Excel, and that is a solver. So if you want to do some numerical solutions, try experimenting with the Excel solver. And Excel solver will try to iteratively adjust some numbers unless things fit and give you what you are looking for. Excel solver is often not installed in your first installation because it is not used by most people. So you may have to install that feature in your Excel installation. Okay, so you may, let's put in some numbers and let's see what we get. And let's come here. So let us assume that, this is an example, that lambda is equal to 1 per year, equal to 1 per year. And let us assume that the threshold reliability is equal to 95%, 0.95. Then, for a single module, your MTTF, let me give you the results in form of a little table. That is equal to 1 year, obviously. and Tm is equal to 0.05.